In this video, we will be looking at more simple trinomials. So we're going to start off with an area example. If you remember from more greatest common factor, you'll remember that if you take an area expression and factor it, each unit will be either a length or a width expression. So first thing, we have x squared plus 12x plus 32, and it represents the area of a park. Now we're going to factor this. Because I see three terms, I do know it's going to be a simple trinomial. So just a reminder, we're going to multiply the product to the constant, which is 32, and we're going to add up to the coefficient of x, which is 12. So to multiply to 32, well, you have 2 times 16, but that doesn't add up to 12. 3 doesn't work, and you have 4 times 8. And 4 times 8 is perfect because 4 plus 8 is 12. So our area will be x plus 4 and x plus 8. And then each bracket will be one of the dimensions. And it's really your choice what you want to call what. So for the length, I personally like to choose the bracket that looks like it's going to be bigger. So I'm going to say it's x plus 8. But if you said x plus 4, that would be perfectly fine. And for the width, I'll just do the other one, which is x plus 4. Now that we have these expressions, let's go to part B. Find an expression for the perimeter. Now just a reminder, perimeter is 2 lengths plus 2 widths because we're just adding all the sides of the rectangle. So perimeter, 2 times, well, our length was x plus 8, and then for the width, 2 times x plus 4. And now it's just a grade 9 distribution. So I'm going to take the 2 and bring it into the first bracket carefully. 2 times x is 2x, and 2 times 8 is 16. And then for the next one, I'm going to multiply the 2 in. So 2 times x is 2x, and 2 times 4 is 8. And now it's just about collecting some like terms. So I have 2 x's and 2 x's, that's 4 in total. Then I have 16 and 8, that's 24 in total when we add them up. And now we have a few follow-up questions just with a mini substitution. So if x equals 3 meters, what is the area of the park? Okay, well, they're telling me to put 3 in for x in the area equation. So the area equation was x squared plus 12x plus 32. So instead of x squared, I'm going to write 3 squared. And then instead of 12x, I'm going to write 12 times 3. And the 32 doesn't have an x attached to it. And now it's about bedmass. So thinking about bedmass, we do brackets first, but there's nothing to simplify in the brackets. Next, we have exponents. So 3 squared, I will do. And 3 squared is 9. And then I'll rewrite the rest. Next would come division, but there's no division. So after that, we have multiplication, which we have right here. 12 times 3 is 36. And then finally, addition. So 9 plus 36 plus 32, and we get 77. And I'm going to add the meters because they did tell us x was 3 meters. All right, the next one, if x equals 3 meters again, what is the perimeter? So I'm going to go to my nice simplified perimeter expression. So instead of 4x, I'm going to write 4 times 3 and then plus 24. And here all we have is a multiplication and an addition, and we know multiplication comes first. So 4 times 3 is 12, and then 12 plus the 24 is 36 meters. So there it is, a quick little area refresher for if you factor an area expression, each unit or each bracket will represent either the length or the width. The next thing I want to look at is a little extension on simple trinomials that combines your greatest common factor. So if we look at the next few examples here, you will notice that many of them have a coefficient in front of the x squared. And some of them even have an x cubed, which is problematic. And we know a simple trinomial should always be 1x squared and then an x, and then a constant. So we have to use our knowledge of greatest common factor and see if we can take out a GCF to create a simple trinomial. So the reason we started with greatest common factor is because that is the first question we should always ask ourselves. So if I have 3x squared minus 6x minus 105, this is definitely not a simple trinomial because of the 3. So let's just see, can I divide everything by 3? 6 divided by 3 works, and 105 divided by 3 works. So we're going to take out a 3. Now in terms of the variable, they don't all have an x in common, so I can't do that. So just a reminder, once we've selected our greatest common factor, we're just going to divide it out. And we're going to make sure to write that GCF out in front. 3 divided by 3 is 1. So now we just have a nice 1x squared, which is the goal. Negative 6 divided by 3 is negative 2x. And the 105, or negative 105 divided by 3 is negative 35. Now we have a nice simple trinomial, so we have to factor another part of this. So we're going to start with our product, which is the constant of negative 35 in that bracket expression, and the sum should be negative 2. So because the product is negative, I do know I should have one positive and one negative number. So, if you try to divide 35 by 2 or 3 or 4, it's not going to work. But the minute you divide by 5, you get 7. And if we make the 7 negative, we do get negative 2. So that's perfect. So I'm going to write the greatest common factor. It can't disappear. And then remember, for a simple trinomial, we're just going to write the brackets, each starting with an x. So x plus the 5, and then x minus the 7 for those magic numbers. And there it is. You're combining both factoring methods together. Okay, for b, I don't have a problem with the coefficient because there's nothing in front of that x to the 3, but if you look at the 3 terms, they all have an x in common, and it doesn't follow that typical x squared x constant format. So we do have to take out a greatest common factor of x. And all that's going to do is drop each exponent by 1. So make sure you still write that greatest common factor out in front, or else you're changing the expression. And then x cubed divided by x just drops down to x squared. And then x squared divided by x is just x. And then at the end, the x's cancel out and you're just left with that constant. Now it's product and sum. So we want the product to be the negative 8, which is the constant, and the sum to be the negative 7. So again, I do need a positive and a negative number. And you might try to divide by 2 and you get 4. But if you do negative 4 and positive 2, you're going to get negative 2, so that's no good. And you might think that you've run out of options, but don't forget, you can always do 1 times a number. So 1 times negative 8 is negative 8, and then if we add them up, we get negative 7. So that's perfect. So don't forget about that 1 combination. So x plus 1, and then x minus 8. Okay, for the next one, we have a 2 out in front, which is problematic, but all of our terms are divisible by 2. So I want you to pause the video here. Try to do that greatest common factor, and if you feel confident with that, go on and finish off the simple trinomial, then come back to check your work. So if we divide everything by 2, you're left with x squared, subtract 5x, subtract 36. So I just divided all the coefficients by 2. The x's were not affected. So now we need a product that's negative 36. So I need a positive and a negative number. And I need a sum that is negative 5. So you might try to divide by 2 and you get 18. Making one of them negative doesn't work. If you divide by 3, 3 and negative 12 gives you negative 9. If you divide by 4, you get 9. 4 and negative 9 is perfect. You add up to the negative 5. So we're going to have 2 times x plus 4 and then x minus 9. All right, for D, I have negative 4x squared plus 24x minus 36. A reminder, whenever your first term is negative, you have to factor out the negative. And in fact here, the 4 can be divided out as well. So our greatest common factor is -4. Notice for all of these trinomials, because I do want to make them simple, we can divide everything by whatever that first coefficient is. Now sometimes that might not work because it's just a common factor, it's not two methods rolled up in one. But when I do want to see both methods, this will happen. So when I do -4 divided by -4, we get +1, perfect. 24 divided by -4 is -6x's, and then -36 divided by -4 is +9. And now the product has to be +9 and the sum has to be -6. Now remember, to get a positive product, both numbers are positive or they're both negative. Because my sum is negative, that means they should both be negative. So to get 9, be 1 times 9, but -1 and -9 adds up to -10, or -3 and -3, which is the perfect combination because that's the combination that adds up to -6 as well. So -4, and then bracket x minus 3 and x minus 3 again. All right, 2 more. So for E, we have 20x cubed plus 60x squared plus 40x. So if you try to divide all the coefficients by 20, because we're trying to get rid of that 20, it works. And not only that, all 3 terms have an x in common. So we're actually going to divide out a 20x. So why don't you go ahead and pause this video, do your GCF, do your simple trinomial, then come back to check your work. All right, so when you try to divide out the 20x, you're going to be left with 20 divided by 20 is 1, x cubed divided by x is x squared, that was the goal. 60 divided by 20 is 3, x squared divided by x is x, 40 divided by 20 is 2, and the x's cancel out. So we need a product of the constant, which is 2, and the sum is 3. The only way to get 2 is 2 times 1, and 2 plus 1 is 3, so perfect. When the numbers are smaller, there tend to be fewer options, and then that makes your life a little easier. So here's what we have. The GCF at the beginning, then x plus 2 for the first magic number, x plus 1 for the second magic number. All right, last one. So I want you to pause the video here and try the whole factoring on your own. So look for your greatest common factor, then do your simple trinomial, and then come back to check your work. So our GCF here is 2, mainly because I want to get rid of that 2 and all 3 of these terms are divisible by 2. There's no x in common, so I can't divide out an x. So we're just left with x squared, subtract 5x, subtract 14. I divided all the coefficients by 2. My product should be the constant in the new bracket, and my sum should be the coefficient of x, again, in the new bracket. Don't go back to the original. We want to look at the simple trinomial bracket. My product is negative, so I need a positive and a negative number. And to get 14, the only way besides 1 times 14 is 2 times 7. And if I make the 7 negative, I get -5. Be careful here with what you make negative. If you made the 2 negative, they would add up to +5, which doesn't actually match our sum. So be careful with your sign. So 2 bracket, x plus 2 for the first magic number, x minus 7 for the second magic number. And that's it. So sometimes you will require 2 methods. So that would be maybe a greatest common factor, and then if you have a trinomial, the simple trinomial product and sum method.